So we're going to draw a labelled diagram for this situation, and we're going to use the diagram to form equations. We've got a suitcase, so firstly let's draw a suitcase. It looks surprisingly like a cup of tea and a conker. It's got a weight and it's being pulled across some rough ground. Now the suitcase is not falling through the rough ground, so there's a normal reaction acting vertically upwards. Its normal reaction is at right angles to the ground. Now it's being pulled by a force which operates at 30 degrees to the vertical. It's a rough ground, so there's friction, and the friction opposes the motion, so the friction works in that direction. The friction always tries to stop things being pulled, so it's in the opposite direction because the suitcase is travelling in this direction. Now the fact that it's going at constant velocity means there's no acceleration, which means there's no force, there's no net force, there's no resultant force. So things are in equilibrium in this situation. So because of that we can start forming equations. So what we're going to do is to resolve the forces horizontally and vertically. Let's do vertically first. This force here has two effects. One is to help to pull the suitcase in this direction, but it's also helping to lift it off the floor. The person doesn't want to lift it off the floor, but because their arms are pulling the suitcase and their arms are in this direction, part of the effect is to pull it upwards and part of it is to put it horizontally. So what we can do is we can think of this force as acting horizontally and vertically, and we do this by resolving forces. So this force P has two parts to it. One is upwards and one is onwards. Now, why is it cos 30? Here's P, that angle is 30, so it's P times the cosine of 30, because this side is adjacent to that side, and cosine is the ratio of adjacent with hypotenuse. The other one, you can think of it in two ways, sine 30 or cos 60. Sine 30 and cos 60 are the same, they're both actually equal to a half. So you can either, so the first thing to do is to think, well, it's cos 30 because that angle is 30. So if that's cos 30, the other one must be sine 30, going alongwards must be sine 30. Or you can think it's the cosine of that angle, which is cos 60. So you can think of this in two ways. Personally, I prefer sine 30. Some people prefer to think of it as cos 60. Doesn't matter. You can pick either of those. So let's resolve the forces vertically. So we get P cos 30 plus R, that's upwards, and that equals mg. Because there's no resultant force vertically, it's not moving up, it's not moving down, so the upwards force must equal the downwards force. Now if we resolve horizontally, and it is important that we get used to writing out what we're doing here. So if we resolve horizontally, the force to the right, well, it's P sine 30 or P cos 60, doesn't matter. I'm going to write P sine 30. Cos 60 and sine 30 are the same. So that's the force which is acting to the right. And because it's a constant velocity, that means there's no acceleration, so there's no resultant force. So because there's no resultant force, the force acting to the right must equal the force acting to the left, which is F. So that equals F. So that's all that this question is asking for. It's asking for a diagram to form equations, which we've done. Later on in the course we'll be looking at the connection between the normal reaction and friction.